Hi, everybody. Thanks for coming in here. I'm super happy this many people were interested in this. I'm Nick. I do things at Puppet Labs. Mostly I write documentation, which you can see on our website at docs.puppetlabs.com. You might remember me from last year. I was up here with like a comedy bit about how to not do things with Puppet, or how to make Puppet do anti-things. That was pretty fun. I liked that. But to make up for it this year, I thought I'd come back and talk about how Puppet works when things are working properly, and about how Puppet actually does what it does. But I also decided that my goal for this talk was going to be total impracticality, because I've got like a personal brand here, man. So I'm going to talk about Puppet's internal subsystems, the plumbing, the pipes, and basically as many of those pipes as I can fit into half an hour. We'll be going pretty fast. It might be a bit chaotic. This is kind of going to be the code tour equivalent of those glitchy Super Mario speedruns videos where they finish the whole game in like 3 minutes. And also, I might not finish the game on time, so in that case, it'd be more like some kind of Super Mario fail video. But I like those too, so that's OK. So what does Puppet do, really, when you get down to it? It configures a system according to a description written by a user, and it does that in a few main steps. It gathers system information. It compiles a catalog that describes a desired system state. It goes through that catalog in order, checking each resource and making changes if necessary. And then it reports on what happened during the run. One of the things that make Puppet's internals kind of different is that these steps can be split across a few different systems, or if you're running Puppet Apply, they can all happen on one box. If you use Puppet Agent and Puppet Master, then the system info comes from the agent, the master compiles the catalog, and the agent applies the catalog and sends the report. But in both cases, either Puppet Apply or split agent and master, they're using a lot of the same code paths. Actually, I think, although I haven't tried this, I think you can make Puppet Agent work like Puppet Apply and compile its own catalog by hacking around with a special config file called routes.yaml. But I might be forgetting about some hard coding somewhere, and never try that, please. Anyway, mostly I'll be talking here about how things happen in agent and master Puppet, leaving Puppet Apply as kind of an exercise for the viewer. All right, we're getting started. At some point, someone ran the Puppet Agent command, which looks like that. We're all familiar with that. As soon as that happens, it kind of bounces us around the code base for a while. And it goes a little something like this. It starts with the actual Puppet binary. Then it goes to Puppet util commandline.new.execute. Then Puppet application.find, Puppet application agent.new, agent.setup, agent run command. Most of what it's doing in there is initializing settings and handling CLI arguments, because it turns out that that stuff is actually pretty complicated. For now, we're going to jump straight to the agent application's run command method, which is where it kind of starts to get down to business. Here's a snippet of the code that kind of summarizes what's going on. Ignore the wait for certificates part. That's a different talk. But we see that it needs to obtain some kind of daemon, and then it calls one of two method calls that do something with that daemon. You can see that one-time daemon or main daemon, depending on what's going on here. Here's the body of those two functions side by side from further down in the file. The one-time method calls daemon.agent.run, as well as daemon.stop, and then it exits with an informative exit code. The main method calls daemon.start, and then leaves. Ignore that listen part. That's for Puppet kick. It's deprecated. Never use that. So that leaves us with the question of where that daemon comes from and what it is. Further down in the file, we see def daemonize process when. This daemon comes from Puppet daemon.new. So we already kind of saw that everything we care about is going through that daemon object that we get from this call. It has a stop, start, and daemonize method. It also has an agent attribute, and the agent attribute has a run method. That's all we know about the daemon at this point. So at this point, we're out of command line land. The agent has already gotten kicked off, and we are in daemon land. Daemon land is a terrible place, and we should get out immediately. Actually, though, I'm going to digress for a moment. Do you all remember what Luke said yesterday about how Puppet is kind of a transition point between its first 10 years and the rest of its life? we've just reached a point in the actual code where you can see the border between those two places. We're about to hit 2 layers of abstract classes that are wedged in between the agent application and the part of the code that actually does what we think of as Puppet agent. We have Puppet agent, which is a general class for triggering a run of another class. That's a direct quote from the comments of the code. We actually made an instance of that during the agent application setup phase, which we glossed over. I mentioned that we were mostly doing setup of settings, but this was something else that we did. Then there's Puppet Daemon, which takes either an abstract agent of some kind or a server of some kind, or both, sets up a network listener sometimes, forks a process sometimes, and periodically runs the agent if it got an agent and not a server. It might live a long time and run the agent many times, or it might just run the agent once and then exit like it does with one time, or on Windows, which always uses one time. And interestingly, it looks like both Puppet agent and Puppet Daemon can both handle run splaying, like where you splay the runs out over a period. So that's some weird duplication. I think they're both used in different cases because you can splay a one-time run as well. Also, there's a scheduler class mixed in there as well, which we're not going to get into right now. That's a lot of layers of abstraction. And it's mostly there for historical reasons, sort of. We're seeing code reuse in a spot where we probably don't need it, and we mostly don't want it if we're trying to understand what the code does. But if you look back, it actually does make a lot of sense. The Webrick Puppet Master and Puppet Agent both spawn processes that go into the background on Linux-like systems. And we also used to have a thing called the Puppet Q daemon. And at some point, it must have seemed likely that we would need other things that also need to run in the background. Since that's 3, that's a movement. But it turned out we actually didn't, really. And if we did, they tended to be their own sort of thing, like PuppetDB, where they're managing their own life cycle. They don't need a babysitter in the Puppet codebase. Also, you should never run a Webrick Puppet Master. And also, the Puppet Q daemon was kind of a horrible hack that PuppetDB killed off. So that leaves us basically with Puppet Agent. Also, the memory bloat problems that Puppet Agent used to have, if anybody remembers that back in the 2.6 days and possibly earlier, those kind of made us rethink the value of a heavyweight, long-lived daemon process. So now in POSIX, the daemon doesn't really do anything. It just kind of sits there, and then it forks a completely separate, short-lived process each time it needs to do an agent run. We did the same thing on Windows first, actually, where the daemon does even less than it does on Linux these days. Both of those seem to work a lot better than what we used to do. And as you might have heard, we're starting to get into native code these days. So my guess is that both of these classes that we're looking at might be kind of short-lived, but I couldn't say for sure. The end result, once you get through all of these layers of indirection, is that the daemon runs the agent, and then the agent runs a class called Puppet Configurer. And then we call the run method on it. Which brings us to the configurer. The Puppet Configurer is what we are usually actually thinking of when we talk about the Puppet agent, because that is the thing that retrieves a catalog and applies it. Historical trivia, it looks like Luke split this class out from the Puppet agent class back in 2009. And most of the real action in this class happens in a method it has called runInternal. Here's a little snippet of that. I'm going to try and skip some of the complicated stuff that this class does in order to, for example, make environments work correctly. But basically, it makes a report object and sets us up to log events to it. You can see that over where we say puppet util log.newDestination report. It also calls a getFacts method and prepares to use the agent's facts, which it gets from that, as query options. By the way, it gets those facts by calling this, which we will talk about in a little while when we come back to the indirector. You're not expected to understand this yet. Then the configurer retrieves a catalog. We see this prepare and retrieve catalog method, which takes the query options that we saw, those facts. And then it applies the catalog. All of these short methods calls that you're seeing in these code snippets are methods that are defined elsewhere in that Puppet Configurer class. It's quite a big class. It does a great deal of stuff, but if you're reading the code, you'll find it's a lot easier to understand this class than it is to understand the daemon or the agent, just because you don't have to bounce around quite nearly as much. If you are interested in reading Puppet's code, I would recommend sort of having side-by-side with a global search tool, because a lot of the time you're looking for where a method comes from. There's a lot of mix-ins, there's a lot of inheritance in the Puppet code, there's a lot of methods that seem to come from Mars. So where next? We just saw that the configurer both retrieves a catalog and then applies a catalog. And that's kind of a fork in the road. Both getting and applying hide a lot of complexity. So I had to decide which to go into first. And I'm going to start with applying because I actually barely understand it. That's the harder one. So excuse me. I'm kind of going to just shout some class names and get out of applying the catalog as fast as I can. Which brings us to the transaction. This is again some of Puppet's older code, and this is where the real meat of Puppet is happening. In the configurer, we get a catalog object somehow, which we'll get back to that, and it is an instance of a class called Puppet Resource Catalog. That's one of the most important classes in Puppet. This catalog object contains a bunch of instances of Puppet Resource, along with some other stuff, including edges and a list of classes. If you actually just hit the catalog endpoint on the Puppet master, or if you get a catalog from PuppetDB, which caches all of the catalogs, you can kind of look at this data structure directly and see what all's in it. It's interesting to do. I recommend it. This Puppet Resource class, it's actually just an abstract representation of a resource. It's pure data. It's nothing but data. All it does is describe the desired state of that resource, but it can't affect the target system. It doesn't have any methods, it doesn't have any side effects, anything like that that would actually go out there and configure a system. So once the configurer gets this catalog full of abstract resources, it uses a method called convertCatalog, which is shown here, and it does its real work by calling a method on the catalog object called toRal. This creates what's called a RAL catalog. RAL stands for Resource Abstraction Layer. This is sort of the idea that you can have an abstract description of some type of resource, like a service or a package, and then have multiple concrete implementations of that representation. So that's Puppet jargon from way back in the day. That catalog's toRal method returns a copy of the catalog, except that every resource in it has been transformed. It's been replaced by the result of calling the toRal method on that individual resource. This code path is a little hairy to get into deeply, but the result is that now instead of being plain data, all of these resources in the catalog are now instances of a resource type class, and each of those classes inherit from the Puppet type class, like that. There's a lot of metaprogramming that goes into creating an instance of a Puppet resource type, but you see these in plugins, like in modules from Puppet Forge that implement custom resource types and custom providers. It usually uses these DSL methods like type.newType and all of that stuff. Each of these new resource objects actually have methods that will call provider methods, which in turn can cause major side effects on the target system, which is the point of running Puppet in the first place. At least I believe that's how that works. That's my understanding, is that these objects have methods that call methods. Anyway, once the configurer has a RAL catalog, it calls the apply method on that catalog. You can see in this apply catalog method, down in about the middle, inside that benchmark block, we say catalog.apply, and we give it the options. Options is where things like tags and ignore schedules comes in. You know how resources can have tags, and you can cause Puppet Agent to only run certain tags, and you can cause Puppet Agent to always run resources that are scheduled instead of just waiting for the schedule. That's where that enters the picture. If we skip over to the Puppet Resource Catalog class and take a look at that apply method that we see being called here, we see that it creates a transaction, and then it calls the evaluate method on that transaction. And this is basically where I get lost when I try to read the code. Welcome. This is an area of code where actually I'm pretty sure that Luke has a pretty good map of this still in his brain, because I've heard him talk about it before. And a bunch of people on the client team also understand it very well. But I just haven't grokked it yet. This is one of the things that I'm interested in looking into more. Maybe I'll take a debugger to it one of these days. But in the meantime, we're just going to gloss over that a little bit. What I do know is that the Puppet transaction class receives a RAL catalog that we were just talking about. That's the catalog full of live resources. It also receives a prioritizer. Now, that's how we implemented things like manifest ordering. It just decides, given equal weight of 2 given resources, which one goes first. And it also receives a report that it can log to. In addition, it creates an event manager and a resource harness. And it has the ability to ask the catalog object to create a relationship graph from itself. And then it calls the traverse method on that relationship graph. And at that point, I'm out. Somewhere in there, probably in the resource harness, it ends up calling provider methods to check whether the resources are in sync on the target system and modify them if necessary. But I'm honestly still trying to figure out how, and I'm really sorry about that. So my moment of shame, we're going to go back to the place where we retrieved the catalog back in the configurer and see how that actually happens. We remember that we got a catalog, and we used a method called prepare and retrieve catalog. This has a special case for Puppet apply where it can take a prepackaged catalog, but when used as part of Puppet agent, this method and its helper methods will try to retrieve a catalog from the Puppet master, which it does like this. Result equals Puppet resource catalog dot indirection dot find, and then it receives a bunch of arguments. We see that it takes the node name and it takes some query options. This is what's called the indirector. You might have heard that name before, usually preceding directly somebody changing the subject. And it's just that little call there, that catalog.indirection.find. And the name indirector might already tip you off that we're going someplace odd, but it's actually pretty simple to understand once you see where it's going, which is all over the place. The indirector is a globally configured, abstract way to obtain certain kinds of data. It works like this. Puppet's Ruby code includes a bunch of classes, all of which represent some kind of data. In this case, we're working with a catalog object. And these classes that represent data, they just implement whatever makes that data type special, have methods for working with that data type. This is just standard object-oriented programming. But then some of them, the indirected ones, they do one more thing. They extend a module called Puppet indirector, and then they use this method call called indirects. They give it a short name for the indirection that they want to have, and they can optionally specify a terminus setting for modifying that configuration. Whenever one of Puppet's internal classes does this, it gets what's called an indirection attribute. That's an attribute which is an object that has 4 special methods: find and search, save and destroy. So almost every time you want to interact with an object of that type with these indirected classes, you use these special methods to get at them or get rid of them or send them somewhere else. So like when the agent decides it needs a catalog, it uses catalog.indirection.find. Any class that indirects has 2 globally configured termini, a regular one and a cache one. And these termini are the code paths that actually obtain or create objects of that type. In the code, all of these termini are located at libpuppet indirector and then some sort of subdirectory underneath that. The idea is that when Puppet is initializing an application, it sets appropriate global values for all of the indirections it plans to use. And then you get the appropriate, well, you being, I'm talking to you as if you're some kind of internal class inside Puppet, you know, standard usage of the term. When you get any sort of object of that type via the indirection, you get the appropriate behavior via that global configuration. I realize that sounds a bit complicated, but the idea is with Puppet Agent, you have the catalog using the REST terminus, which means it has to go out over the internet to get a catalog. The report indirection uses the REST terminus, which means when it's sending a report, it has to send it out over the network. And the facts indirection uses the factor terminus, which means when it tries to obtain its facts, it gets them from the local system using factor. On the other hand, with Puppet apply, the catalog terminus is set to compiler, which means it has to compile its own catalog instead of going out over the network. Report is set to processor, so it will process its own report instead of sending it out over the network to a Puppet master. And facts is still set to factor, so it still uses the system's local facts. So that's pretty cool. It lets you sort of use the same way to get at a given data type, but change the behavior based on the configuration. Oh, and I should mention the cache behavior too. This can sometimes get a little bit weird, and it's easy to gloss over it when talking about the indirector. Every indirection also has a cache terminus in addition to a main terminus. And whenever you call find, the indirection will always look in the cache first and return the cache content if it finds it. And if it ever does go to the main terminus to fetch an object, it'll save it in the cache. It's kind of primitive cache behavior, actually. There's no time to live limit on any of these caches. Wow, sorry. And the stuff in them will tend to live forever, which is generally not what you want. So you'll often see workarounds in Puppet's code to avoid hitting the cache. So for example, in the configurer, we see that when we call catalog.indirection.find, we also add ignore cache true to the query options to make sure that we get a fresh catalog. There's another place in there where it's actually specifically trying to get a cached catalog, and it'll set ignore terminus to true. Also over in the master, there's a write-only YAML terminus that's used as the node cache to keep the Puppet master from getting stale data. The point is you kind of have to do some finagling to make sure that you're getting right with the cache and not accidentally getting the wrong data that you don't want. So okay, why the indirector? It did take 5 minutes to explain that. Why do global configuration and why use a fairly rigid interface that everything gets and that you sometimes have to go to some effort to work around? It really does make sense in context. The whole point was code reuse. I was just talking to Luke about this on Friday, by the way. Make sure I had my memory straight. Luke was writing this code around the end of the Puppet 0.24 era, which I'm trying to remember when that would have been. I joined in the end of 2010, and 2.6 had just come out. So this must have been 2009 or 2008. Among other things, he was envisioning trying to wire these different behaviors together outside the actual application code so that you could sort of make new applications on the fly just by changing the configuration, which seems kind of radical and weird. But at the time, we were thinking about we weren't really confident that Puppet had actually reached its final form. We had the agent and the master, and we had the standalone Puppet apply, although it was going by a different name at the time. All of these were going by different names. This was Puppet D, Puppet Master D, plain old Puppet? Yeah, that's right. But since it was evolving very fast, and Luke wanted the ability to change its behavior pretty radically if that turned out to become necessary. In practice, that ended up being a little less important than we thought. It did enable fast movement on things like PuppetDB, where we already had a convenient place to hook new stuff into. And it does enable occasional experiments like the static compiler terminus. Raise your hand if you've used static compiler. Oh, I can't tell if yeah, there's one in the back. All right. But it ended up being kind of overkill for a lot of use cases, and it definitely ended up being a little hard to understand just because of the global configuration and the fact that you need to be you kind of have to have the whole state of the application in your head if you want to really know what that catalog.find is doing. It's definitely a good idea at its root, though. Because you always need some way to abstract and reuse certain code paths. I think what the engineers working on the new Puppet server have been finding is that it seems to be easier to do that in code at the place where you compose services together instead of doing it via configuration that gets accessed from really deep in the code paths. So that way you kind of make the decision close to the surface level, and everything behaves predictably from that point. So for example, there's a new CA service, a built-in closure that's used in the new Puppet server. And they route incoming requests to it kind of at the HTTP server layer. We're using this framework called TrapperKeeper to handle that. I think that's the opinion of the engineers working on the Puppet server, but I actually didn't get a chance to grill them on the indirector yet. So that'll be another fun one in the coming week. But at any rate, that's the indirector. Whenever you see any of these indirection.find calls throughout the Puppet code, what it's doing is checking global configuration to decide what handler to use, and then using that handler to get an instance of that object from somewhere. In the agent case, that catalog request gets turned into an HTTP call to the master with the agent's facts given as the query options. Puppet does this as a post request with the facts as the body of the post. And at this point, we've left the agent for the master, which brings us to the master's HTTP interface. Usually the master is running via a rack server. Rack is a standard interface for running Ruby applications. It's used to run a lot of Rails applications. It's used to run a lot of Sinatra applications that used to be Rails applications. And it works kind of like this. You have a regular web server that's very good at handling HTTP requests, like, for example, Apache. And it gets configured to route requests to some sort of rack server, like Passenger. Apache and Passenger is an interesting combo because Passenger is sort of running inside Apache as an Apache module. In a lot of cases, it's not quite like that. Instead, like with Nginx and Unicorn, you have both running as separate servers, but Unicorn's doing a bunch of stuff where it always expects to be getting HTTP requests from the local system. So there's a bunch of weird ways to do it. The rack server is configured to load some kind of Ruby code and use that code to instantiate something that they call an app object. This is a Ruby object, which could come from anywhere. And the only real requirement of that object is that it has to respond to one method called call. The app object in return gets something predictable from rack as the argument to call, and then it gets to do whatever it wants to craft its response to rack. That's the actual application logic, is once it gets that request, it does whatever and then spits it back out as a response to the call method. In Puppet's case, we get to configure our rack server with this config.ru file. It's a plain old Ruby file that is a special name that rack knows how to load. And we can see that it's basically taking a backdoor to the same path we ended up on back when we ran Puppet agent on the command line. You can see over there that we're requiring Puppet util command line, and we're running command-line.new.execute. That was exactly what happened with Puppet agent. But we also see that we're running Puppet master with this special -- rack option. And whenever we do that, we get this code path. Over in application master, we return Puppet network HTTP rack.new. There we go. That's that app object I was just talking about. Puppet master spits that back and then basically ends. And now the Ruby process that Passenger is managing has access to this object that it can just push requests into and get stuff back from. So now we jump over to that object that the Puppet master spat back to the rack server. We see that the way it handles requests, highlighted in red, is with a Puppet network HTTP rack rest object. This class actually inherits its process method, which we see being called on it there, from the Puppet network HTTP handler module, which is shared code between the rack and WebRick Puppet masters, just so they can both kind of do the same stuff once you get deep enough into the code. Which brings up an interesting thing. I don't actually know how the new Puppet server does this. It might use the WebRick one, but I'm not really sure. I'll have to look into that when I get back too. If we look at what this does in that process method that we just saw get called, it's that network HTTP handler, by the way, we see that we basically extract a bunch of info from the request, and then we search through a list of routes, we find one, and we call the process method on the matching route. And this is where the trail starts to get a little bit fuzzy for me. I know the basics of how this is put together, but I couldn't follow the actual execution path yet. Still need to study up on that one. The salient part, though, happens in libpuppet network http api v1.rb. It's v1 because we're in the process of overhauling Puppet's HTTP API, but this is the classic one. I'm not actually sure how it creates all the routes that it needs and publishes them such that routes.find can match them. But I do know that basically all of the HTTP endpoints in this v1 API are actually just direct interfaces back to the indirector. So yeah, the indirector's back. These request handlers that get formed by the API use the request URL to choose an indirected class. So for example, if we were going to /production/catalog on that HTTP call, which by the way, that is the post call that the agent makes when trying to get a catalog from the master, then it locates the catalog indirection, and it uses the HTTP request method, which get, post, delete, put, or get, to decide which indirection method to call. Remember that the indirection had find, search, save, and destroy, which kind of sounds like a band name. Yeah, that was definitely a band name. And so this request that comes in over the wire ultimately gets handled by whatever indirection terminus is configured for the Puppet master application, for that application, or for that indirection. And in the case of the catalog request, you see we did a post to the production catalog HTTP endpoint. That becomes a Puppet resource catalog.indirection.find method on the Puppet master. And it ultimately goes to the catalog terminus, or sorry, the compiler terminus. We see configure calls catalog.indirection.find on the Puppet agent. The agent makes a post request to the master. The master request handler calls catalog.indirection.find again. The compiler terminus handles it. It makes its response over the wire through the rack server to the configurer as an HTTP response. And then once the agent has it, we go back into the catalog application where it gets turned into a RAL catalog, and we start the transaction on it. This goes into the resource harness and stuff like that, and ultimately calls the provider methods that configure the actual server. So that just leaves that compiler terminus, which gets called on the Puppet master when the Puppet master tries to find a catalog. Unfortunately, this one should basically be an entire talk on its own. So we're not going to go into a lot of detail on it. It's all in a bit of flux anyway. Who here has used the feature parser? That's a few. I actually can barely see anybody. Then actually, OK, yes. There are two completely separate versions of the entire parser and evaluator code path. There's the 3.x version, which is on by default. And then there's the 4.x version, which comes on if you set parser equals future. And they work pretty differently. I actually haven't followed those code paths through, and it's a little confusing because I think they actually share some code. So that's wild. But what I can tell you is the outline of it. Basically, there's a lexer, which turns Puppet code that you write into normalized tokens. So for example, it sees a left parenthesis, and it turns it into this unambiguous symbol/word that just means left parenthesis. And then it does that with the next thing it sees, et cetera, et cetera. Then there's a parser that takes those tokens that the lexer generates and turns them into an abstract syntax tree, an AST, which is sort of a branching tree-like representation of everything that you are trying to say with the Puppet code. That goes to an evaluator, which walks that tree structure and figures out when it needs to add resources or edges to the catalog. And eventually you get that catalog, which can be sent to the configurer and can then be turned into a RAL catalog and sent to the transaction. So like I mentioned a bit ago, the compiler gets invoked by the compiler terminus to the catalog indirection. And the big test is, do you understand that? Do you understand what it means to invoke the compiler terminus to the catalog indirection? Oh, yeah. Yeah, everyone's with me. All right. Good work, everybody. Thanks for coming to my Puppet internals talk. There's a whole bunch in there that we've skipped or glossed over. I think even just this fairly superficial take on the one main code path through the Puppet code, not doing many of the detours and skipping a lot of the really deep stuff, was still enough to show you that there's a lot of stuff inside Puppet. But we've hopefully taken at least a quick look at all of Puppet's most important subsystems. And the next time you start trying to trace a problem, or run the debugger, or sort of try to follow the comments on a bug that you're interested in, or start contributing code yourself, hopefully that gives you a bit more of a map and a bit more of a grounding for talking about these subsystems and figuring out where to start looking when you're trying to find them. And that brings us to questions. Yeah. All right. I am a technical writer. I'm not an engineer. I've contributed code. Wait, did I remember to repeat his question into the microphone? He asked, am I an engineer at Puppet? Yeah.
Wow, thank you.
Thanks. You're welcome. Yeah, right over here.
Do you have a really, really simple diagram?
Do I have a really, really simple diagram?
That someone who's newish to Puppet might have a chance at understanding?
Due to time constraints, I don't currently have a really, really simple diagram. Also due to terrifying complexity constraints. I would really like one. Actually, part of the motivation for doing this talk in the first place, like I said, I maintain the documentation, or at least parts of the documentation. I'm with a large team now. Our technical writing team has gotten great big. I maintain the documentation at Puppet Labs, and one of my motivations for doing this talk was to dig into parts of the code that I had always shied away from and feared before. So for example, the daemon and agent and configurer thing, all the way up into the transaction, that was stuff where I sort of knew it was there and I'd never gotten into it. My hope is that by doing this, I might learn enough that I could actually produce a diagram showing just sort of a map of all of the different stuff. Seeing how complex it was in the process of putting this talk together, I'm not sure how simple I'll be able to get it, but I'm definitely committed to getting something visual and something cool up on the website out of this, because I feel like I've earned it. Yeah, right over there.
What's the most effective way to debug a custom type through the indirector?
What is the best way to debug a custom, sorry, say that again?
What is the best way to debug a custom type through the indirector?
Debug a custom type through the indirector. I don't know that you would. I think you would probably put a, you would probably attach the debugger directly to the resource type. And get in there both on the, you would have to get in there both on the Puppet Master and on the Puppet Agent, because the master uses the resource type as well to do correctness checking for the parameters and stuff like that. But I think you could attach the debugger directly to the type instead of trying to go through the indirector. Any else? Who am I? Yes, there we go.
Code readability is really important for Probably. You know that as a documenter. Are there specific things that you're going to bring to the Puppet engineers and say you can improve the readability by doing this?
I think, oh, sorry, I should actually repeat that question. The question was, is this going to translate into any specific insights that I can bring to the engineers about code readability and about specific areas of the code that could be more readable? Is that a good summary of the question? Yes. Okay. Yeah, I mean, hopefully we can talk about that. But I think in a lot of cases, most new engineers to Puppet run into similar problems that of understanding this that we all run into. So I doubt that it's going to be news to a lot of people. The thing is that, like, Puppet, to some extent, Puppet is complex because it does a lot, and to some extent, it's complex because it's been around for a long time. And we're kind of working on it. That's part of the motivation for moving the stuff to these closure services, and especially breaking the services out into a service-oriented architecture. Once you have a bigger separation between the services and a more visible interface layer between the services, like a much sharper dividing wall between the services. It gets a lot easier to refactor them for readability. Right now, because everything's kind of going through the indirector 3 times before it lands at its eventual destination, it's kind of hard to just go in there with the mission of improving readability without having a larger architectural plan first. And I've been seeing the engineers working on that larger architectural plan, so I believe that they're aware of it and working on it. I'll certainly raise any readability concerns that I see, but I think they're working hard at it already.
All right, I'm afraid we're out of time, but I'm sure you have time afterwards to answer any additional questions.
Yeah, come hang out.
So thank you to Nick.
Thank you, everybody, for coming to my talk.